I would. It is, but that you missed one word. You missed out the linear bit. So linear relationships. You're right. It's a relationship between two numbers. Would you like to?
Yeah, it's like it's like a group of numbers that have like the same pattern almost. Like
Okay.
for
That.
example, like in the video, it was like minus 125
Yeah.
every year. So like it's a group of numbers that follow the same pattern.
So there's an extra word I want in there. Yeah, kind of set it up. What is it? Yeah, that's what I'm looking for. Yeah, you're right. So we've got a relationship. Well, maybe we should write that down. So the relationship between two numbers, shall we say? Keep it simple. Okay. And what is important is we have this word, constant change. Okay? It could, sorry. So that could be a constant growth, but it could also be a constant decay. Growth or decay. Right. So, what you have been looking at is on the computers, you've been plotting values. You've been noticing that they are linear in nature, but what you guys have already done is looked at equations of the lines that will go through, haven't you? Yeah? So this is what we're kind of looking at more in detail. So let's have a look at, we're talking about the thing in the book on page 110, and we're talking rate of change. Now, is there anyone that thinks they know what we mean by the rate of change? Come?
The speed that it changes.
Okay. When you say speed that it changes, what do you mean? Could you give me an example?
So, for example, it's like something's increasing.
Maybe it's worth giving me two examples about the same situation to show that there could be different rates of change.
Like a phone battery charging rates.
Yeah, go for it.
Meaning, instead of like something goes at like 2% every 2 minutes, and goes at 1% every 1 minute.
So 1% per minute.
And 2% per minute. The rate of change, like would be 1% for each one, but the difference in number.
No, there wouldn't be 1% for each one.
I mean,
it would be 1% per minute for the first one, and it would be 2% for the second one. Yeah. So this would be the rate of change, 1% per minute. Okay? So the rate of change itself doesn't necessarily tell me exactly where I am, but it does show what's happening. So every minute. So if I were to plot points of the line on my graphing software, and would they show a decay or a growth? A growth, yeah? So it'd be a growth relationship, wouldn't it? So they, as time goes on, the percentage of charge would go up. Right? How would you compare the two lines if I did that? So let's say this is charger number 1 and this is charger number 2. Just looking at those rates, how could you compare the two? What would you say? Liam?
The second charger would charge twice as fast as the first charger.
Okay, so this one's faster, but what does that look like then on the graph? How would you see that in the graph? Cameron?
if you put the minutes on the y-axis and the amount of percentage on the x, then it would become like slightly higher because it's increased. I mean, yeah, because it's increasing
Yeah,
speed.
yeah, I'd say, so what we said there, be steeper, the line would go up quicker, all right? And this is when we would say, actually we'd have so what we've got to understand today, a higher Gradient. Okay? So we'd have a higher gradient. Now, what does that mean? Well, that means that the line's steep. Liam?
For gradient, isn't that like different kinds of light bulbs? They have like different gradients?
Don't know with light bulbs. You may see the word gradient in terms of colour,
Yeah, that's it.
but that's kind of a gradient of colour where it changes, yeah? So it kind of links to the same thing, it's a change. So the gradient of our line, you also would see gradient in terms of, again, it's different here. Used to mean much more in Switzerland with the mountains. Hills have gradients, yeah? If you have a higher gradient, the hill is steeper, it's harder to get up it, all right? So what we've got when we plot our lines, one line would end up being steeper than another. So what we're looking at is how can we look at this value, this rate of change, how can we go from that to the gradient of the line, all right? So what we can start with is, let's take this example and let's look at some values. So we were looking at x and y values. So what would be the first x value we could consider?
No,
Oh, wait.
dead, like 0%.
0 minutes.
0 minutes.
Oh,
If X,
Well, it is, isn't it?
yeah.
X is going to be our time. Y is going to be
so not 0%.
percentage of charge. Okay? So let's make up some numbers. What's the phone at when I start charging it?
0%.
It never gets to 0. No one ever lets it get to 0.
10%.
Well, 18, I'm going to, because Cameron said it first. Let's start with it's at 18%, right? If it charges at rate 1, what would it be after 1 minute?
19%.
After 5 minutes?
23? No, you wouldn't be. Would you be adding
24?
Wait, would you be adding 20?
23?
24. It's 23.
Yeah.
24.
It's 23 because 5 minutes after.
Are you
it
good?
starts.
2 is
It's
20.
5 minutes after
3
it
is 21.
starts.
It's 23.
It is 20.
23, isn't it?
Yeah.
Because we've already said after 1 minute it's 19, so it's 1 more than 18. After 2 minutes it's 20, 3 minutes it's 21. So it's just add, this one's nice and easy because it's 1% per minute, so every 1 minute, okay? So after 10 minutes it's going to be at,
28%.
okay?
28.
So if I were to draw the graph of that, right, we could plot our points, right? I'm going to put a little wiggly line there because I'm going to start at 18, 19, 20.
Oh, yeah, I remember.
I don't want to go all the way down to 0 because that's not of interest to me, right? But I'm going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Probably won't even fit, look. Okay. So what will it look like if I plot those points? Well, it's going to be 0, 18. It's going to be 1 and 19, 2 and 3, 21, 4. Okay, so it's going to look like this. So it's a constant change, which is why, can I ask, does anyone remember why I'm allowed to draw a line?
Because that shows like a pattern, like it shows the linear relation.
Not enough information for me, sorry, Liam.
Wait, can I check?
Hang on, Steph? Why am I allowed to do that though? What is a line? Cameron?
It's all the possible outcomes of the linear relationship.
Yeah, it's all the possible points. A line is not a line. A line is an infinite number of points that looks like a line. Right? It's important. That's why people don't understand quite often, is they think the line is just a line drawn through the points. But we draw a line because we can't draw an infinite number of points, can we? There's no point putting our pen in an infinite number of times. But we know, if we're following a linear relationship, that if it's 18 after 0 minutes, if it's at 1, where is it after 30 seconds?
0.5.
18.5. You can't have 0.5%.
Yes, you can.
Yes, you can.
You have to be able to. Your phone doesn't jump from 18 to 19. It might not tell
It
you,
doesn't display. That's what I mean.
doesn't tell you, but it will go through that point. And then after 45 seconds, it will be at that point, right?
Yeah.
And it depends how small a time period we go to. There will be that level. Yeah? But again, criterion D, levels of accuracy. Why don't we list those? Why doesn't our phone show us that it's at 18.238%? Because it's not of interest.
Yeah, it doesn't matter.
Doesn't matter to us. We want to know when it's at 18, then 19, then, you know. All right. So we've got all those points. That's why I can have a line. All right. Now, if I then plot the 2% per minute, so let's do y1, but let's do it as y2. So after 0 minutes, let's say it's still at 18. Where would it be after 1 minute?
19.
20.
Oh,
22, 24. So this time if I plot my points,
It's not.
good.
Oh.
What would it be? Charlie, what would it be? What do you mean 32? Is it 32, Charlie?
32.
It's 30.
30.
28.
It's 28.
Oh, this one's 28. That's the point, not the 5.
Because if you take the 10,
The difference
If you
between 1
use
and
the
5 is 4.
it's 10 and
28.
5 is half.
So there's been 5 minutes and it's every 2. So
38.
this one should be 38. Okay, so if I plot those points, this time it's going to be,
It can only go
Still
up
at 18.
1 minute.
but this time every 1 minute is going to go up 2. So, what has happened?
It's got a different. It's got an infinite number.
It got a higher grade.
The gradient is higher. Okay?
And it's the
Now, do you remember, I'll be very happy if everyone can do this, how to write the equations of those two lines?
Is it with like angles?
Desmond?
For the first one, it's y equals
This one.
Yeah.
Y equals
x plus 18.
what do you reckon, Cameron? Yeah? What about this second one? Cameron?
Like 2x plus 18.
Okay. Are we happy with that?
Yeah. Oh, I understand.
So, what we have here is, I think I remember telling you, is that this number here relates to the, no, what's it?
The empty space.
That could be a 1, but
Yeah, that could be a 1.
right, it's the rate of change, isn't it? So this number here, right, is the rate of change in the situation, which is also the gradient, also called slope of the line. So it makes sense. If the rate of change is higher, the line will go up more, doesn't it? Right, what about this 18? Is there anything we could say about the 18? Jack?
It's constant.
Yeah.
But what is it got to do with in
It has to do
the
with-
situation? Anyone else? I've got the same hands up all the time. No? What does the 18 represent in this situation? Hayden? Yeah. Do you remember what I called that? Anyone?
The
Base
zero.
number?
The origin. The origin.
Initial constant.
initial condition.
So that's when we start, isn't it? That's, in this case, it's when time is at 0. All right? And in that, and I'm just going to say in this case, if this is x, and this is very important, Cameron, I hope you're paying attention because I hope you took note of what I said earlier. I don't forget it. Right? It's when x equals 0. Now that's important. Okay? It's also called the y-axis intercept. Yes, Desmond. If you really need to, this is the ideal time and you're desperate, then you can go. All right, so it's our initial condition. It's when x is 0. All right, and it's also called the y-axis intercept, and it's here, look. This is what we've got. Now, in this case, will this line go further into the negative x's? Well, what's...
Extrapolate.
Oh.
Okay, so could the battery ever go below 18?
Yes.
It can. But what can't go below 0? The time. Yeah? So we've started charging. So really this line, I couldn't have another one that did go below 0. That wouldn't make much sense. But that's only because we put it in context. It can, however, if we take it out of context, the lines can go on forever, right? Infinitely long, right? So there's one thing we should now summarize, okay? Which is the rate of change, okay? The rate of change is found by doing, okay? The change in the y variable, okay, divided by the change in the x variable, okay, also known as y2 minus y1 divided by x2 minus x1. Okay? Does that make sense? So we're looking at, well, in this case that we had here, what was the y variable? Charge in percentage. What was the x variable? Time in minutes. Yeah, I didn't write it on my graph, but that's kind of what we were talking about. Okay. Basically, then, for the second one, what is the gradient? Two. The rate of change is 2% per minute. All right. So we ought to be able to verify that what I said here works, and get the answer 2 and 1. So what I'm going to do is I'm going to pick, all right, 2 values. So I'm going to say x1, y1, ignore that's a y2. And I'm going to go x2, y2. Are you happy with that? So this is the x1, this is the x2, this is the y1, this is the y2. Okay, so I'm looking at this line and I'm going to try and find the rate of change from this line. So can you confirm for me that using these numbers, this works? Can you do that? Do it now? So just to confirm this then. All right, let's just go through it. So we have the change in the y variable is, well, y2 minus y1, so that would be 28 minus 20 divided by 5 minus 1, okay? I get 8 divided by 4, which equals 2. So I'm happy with that. What Jacques said is that it doesn't matter which way round. So I could do 20 minus 28 divided by 1 minus 5, and I get negative 8 divided by, which is 2. All right? What about if I did the only other option, which is to say 28 minus 20 divided by 1 minus 5? What if I flip 2? That would give me negative 2. Is that correct or
The
not?
ones have to be in line with the 2.
So what would that mean, Jay? It would. So Jacques is right that you can swap the y2 and y1 around and make it y1. It doesn't matter as long as the x's are the same. All right? You can't swap one pair around and not the other pair, otherwise you'll get a completely different gradient. Okay. Dim.
I was thinking that the y2 and x2 and the x1 and y1, they just have to be in line. It doesn't matter which way around.
Well, it does, because if I don't.
No, I mean what I mean is
I
like
have
the
to
ones
go.
have to be in line with the 2 ones and the 2.
Oh, I get what you mean. Yeah.
It doesn't matter.
So
which way
20 with the 1.
Yeah.
Yeah, and 28 with the 5. Yeah, that can work. All right. It should also work, for instance, if I pick 0 and 10, or 1 and 10, or 5 and 0, because, well, why? Why should it work with any pair of points?
Since it's a constant.
Exactly, that's what I'm asking for. Yeah, because it's a constant, it shouldn't matter which 2 points I pick. All right.
Yeah.
All right. Okay.
I
Cool.
also did it random.
Right, now, the next thing to move on to then is, well actually I'm not going to, okay, I'm going to skip ahead a little bit. Can you turn to page 116? 116, all right? We're looking at practice 2. We have skipped over something, so what I want you to do, all right, is I want you to answer questions 1 and 2 only.
Oh, 1.
Question 1 and question 2.
With or without computers?
Without computers. Yeah?
Is it practice 2 or is it the stay at the top? Practice 2.
Page 116, practice 2. I've written it on the board.
Do we have to put in these as well? Do we have to draw
You don't have to draw out the tables. I would ask though that for question 2 you do write the coordinates out and you show you're working. All right? Right, let's go through this then, just quickly. All right, so A, do we think linear or not?
linear?
So what we're looking at is the x values go 12, 14, 16, 18 and 20. So they go up 2 every time, yeah? So we're looking, that's not, there's no gaps like I did. You pointed out very well in mine that I went 1, then 5, then 10. You know, I didn't have, but this one is nice. It just goes 12, 14, 16, 18, 20. They keep it the same. And then we look at what happens with the y. Well, it goes 32, 37, 42, 47, and 52. So that goes up 5 every time. So what that means is, it's nice and easy. Our change in y, we could write is 5. And our change in x is 2. All right? So my slope is 5 over 2, which I can leave it as.
2.1.
That is 2.5, but actually this is a nicer way to leave it, actually. All right? So that's A. B then, what do you think, linear or not linear?
Not linear.
Why?
Because there's no relation between any of the numbers.
So we've got 9 is 78. 10 is 72. So we're going up 1 in the x, guys. 1 in the x in this case made me go down 6. So to start with, we've got a negative 6 and 1, change in y over x. But then if I do the next one, I've got 12 and 60. Now that is a change in of, so
12 to 2.
2 is from 10 to 12, and what happens? Minus 12, which is the same thing as
Oh.
minus 6 over 1. The next one is 16 to 36. So that is the next one then is we go a change in of 4 in the x, and it's a drop of how much on the y? 24, which happens to be negative 6 over, it's the same thing.
Oh. So
Okay.
it is linear.
So we think B is linear, right? Because it's a constant change.
Yeah.
All right. C then.
It's kind of hard because there's.
So
No,
we've
it
got
could be linear.
2.
It doesn't give us enough information.
No, it's given us plenty of information.
24.
Right. We've got 5.
It's not linear.
36. Right. So guys, let's do this properly. So the change in y goes up 3. The change in x goes up 3. So that's a change of 1. Okay. Then so our rate of change is 1. The next one would be, what did we say?
It's not linear.
8 to 24. So that is an increase of 3, and it goes,
Minus, well,
which is,
4.
so you've already shown that it's not linear.
C is
Because it goes up, then it goes down, then it goes, yeah? Alright. Goes back, it goes up, then down, then back up again. So it's not a constant. What about D then? What do you think?
That's linear.
D is linear.
D's you've got as linear. Okay.
I figured out why, like, just.
Well, actually, you couldn't.
All right, so
Yeah.
I don't, for that one, I don't want the equation. But what were you saying, Liam?
So when you look at it, it goes.
Look at which one?
D.
Okay.
So it starts at negative 2, and to go from negative 2 to 1,
Yeah.
you add 3.
Yeah.
And then to get the y, you would times that by 3, which would be 9. And then you add on another 3 to get to 4, and you times that.
No, it's not quite you
No,
linking
never
things.
mind, never
No.
mind.
Right, can we go through just question 2 quickly then? Right, so it says find the slope of the line. So we've got, and it says A, B, and the little arrow is just saying go between A and B. And you're told that for the first one, A, the first coordinate is negative 3, negative 8, and B is at 12, 10. All right, so to finish this off, all right, the slope to get from A to B then. So we want to know what the change in y is. So the y coordinates are negative 8 to 10. So remember, we could do it either way as long as we are consistent. So I'm going to look at this direction. So what's my change? So I'm going to go 10 subtract negative 8,
18.
which is 18, good, right, divided by my change in x. So the change in x is given by this number and this number, but again, I can't go a different way around, I have to go the same way. So that's 12 subtract negative 3, which is 15. So 18 divided by 15 simplifies to 6 over 5? Okay, could I just ask you then, the reason why it's better to leave it like this as a fraction than convert it to a decimal quite often is because if I had to say that as a rate of change, let's look back at what we were doing. Charging our phone. What would a rate of 6 over 5 mean?
1.
Naya, you've been a bit quiet today. Do you know what a rate of 6 divided by 5 would be? No? Okay. Anyone? Been a bit quiet? Charlie's been a little bit quiet. Okay, go on then. Charlie? Nope. Well, what would those numbers though, the 6 and the 5? What would that mean in terms of charging our phone? I'd be impressed, Jasmine, because you missed the first bit. Would you be able to go do it? Oh, that's just a different version. Well, what does it mean in terms of a rate? Jay?
It means that
Owen? There you go. Perfect. 6% every 5 minutes.
Or 1.2% every.
But I didn't ask for that. But you're right. It's if I leave it as 6 divided by 5 rather than change it to a decimal. As Liam changed it to a decimal, it's 1.2. That's 1.2 per minute. But just as equally, I can say it's 6% every 5 minutes. All right? It means the same thing. Right? And it does actually, as we progress, it's easier to leave it like that and talk about it that way. All right? So, you should be able to finish off B, C, D, and E in the next 6 minutes. What would that be as a rate, questions per minute?
How much time do we have left?
6 minutes.
6.
4.
1.5 questions a minute.
All right, yeah, 1.5 questions a minute. Go for it.
I think Adriana's just going to go to French.